Good morning, good morning, good morning. See where we left off yesterday. So we're in the process of moving or actually taking the parts that matter in terrain tessellation test and putting it in a utility HLSL file that will be included. So if we have a shader that wants to do tessellation, we just include that file and most of it will be done for us. So just a way to group everything tessellation related in its own file, so we only have to change it at one place. Because if we take a step back, we're in the process of updating the tessellation implementation for all of our terrain, water and snow and so on. Doing a little bit of a topology fix up as well. But okay, so when we left off yesterday, we have this file stage tessellation HLSL, which will be included by any shader file that wants to do tessellation. And what we get for free here is we get a vertex shader. So we pretty much limit here what data we're gonna send down. We might need to do some variations here later on. We might do something like this if it's possible. I'm a little bit worried about these, but we'll see. So we get a vertex shader, which pretty much just takes something in object space, converts it into world space and clip space. We need clip space here because we are gonna do some culling based on it, I reckon. Then we have our hull shader control point output and our hull shader patch constant function output. So what I'm gonna do is in this file, terrain tessellation test, we're gonna move everything tessellated related from this one to this one, and then we're gonna include this one in this one and see if it works. If that works, we're also gonna create a stage geometry shader, or stage geometry HLSL, where we have this last topology fix we do. And when both of those works, we are gonna take a look at, so currently I have procedural grass light, terrain procedural grass, terrain procedural snow, terrain procedural water. We're gonna take a look at all of these and clean it up. I think we're gonna remove these two. I don't use them anymore. Snow, we're gonna remove this one as well, I reckon. And update them so they use the new tessellation and geometry features. I'm gonna add some extra. I've also been having some plans about splitting. So right now terrain procedural grass renders both ground and grass. I'm thinking about having thoughts about splitting this one into terrain ground and terrain grass. I think both will be optimized quite a bit. So they will pretty much render the same mesh, initial mesh, but the grass will cull every part which doesn't have grass pretty much. Yeah, so I think that's what we're gonna do today. I'm not entirely sure of how I want to handle. So when we do this tessellation here, I wonder how general we can keep this one or how many versions we're gonna need. Or we can just do it with flags pretty much. We'll see. Our geometry shader here is gonna take a domain shader output. I'm not too sure about that. Yeah, I was having plans about letting the domain shader. We have tessellation shaders, and the domain shader is probably gonna be specific enough so that we can't include it in a include file. I've done it over here instead. Okay, let's see if this works so far. I just want to know tessellation, space camera pose. I think we have what we need. And this one is actually quad, so it's a quad. Tessellation we're doing here. Terrain tessellation test. I'm gonna keep these here for now, see what happens. stages. Something like that, and doing that should mean that we can remove this one, this one, this one, and this one. And this one. Something like that. Would be beautiful if we could calculate the position, if we could. Yeah, we're probably gonna create some domain related, or probably gonna do a stage domain HLSL as well, but I'm wondering if that should only contain a few methods rather than a full stage. It's this one I'm a little bit worried about. It's very, very specific. So when it comes to ground and water, we are probably just gonna return the height, much like this. For ground, we're gonna return height, just like this. But for water and snow, we're gonna do a lot of additional stuff. Although, actually, it all depends on I mean, we could do it here, but we're gonna do it multiple times per point, if so. Nah, I probably want my domain shaders to be handled at this point. But I mean, I think we can do it in a pretty nice way. Main shader output. Good morning, Harukanan. Good morning, Geralt. So I'm wondering if, yeah, domain shader, we're gonna create a stage domain, but it's mostly gonna be methods. It's going to define this one without color, and the file that includes it is either gonna define its own domain shader output or use the one in the HLSL file. Yeah, we have the normal to handle as well. This one I'm a little bit worried about as well. I will see. Actually, maybe we can do it like this. Let's see if this one works. And then we create... output stream. I just want to double check as well if... do we have access to whatever we have appended here? Like, can we append stuff to it and then read it? Do stuff with it. So what do we have? Triangle stream. Stream output object. If I remember correctly, we only have 2 methods. Yeah. Could do some hack. I'm not too sure about that, but like we could create a geometry shader method that returns an array of domain shader outputs if it's an empty, and that's a restart script, but that introduces a for loop here, and that's ugly. It's just that we have... Okay, I wonder if... Now, we should probably be able to do... I want to try this. We should be able to do... Hope we can do... So, output stream 0. Do something. Dot... Position VS. Yeah, let's try that soon. I just want to see if this one works. So instead of having the vertex shader and hull related shaders and methods in this file, we just do this. That's about it. We can lower this one as well. So what do we do? Max vertex count, we have 1, 2, 3, 4, 8, right? Okay. No errors, that's nice. And then I want to test this one then. So I guess to make it a little bit quicker, we disable these two. And hope for the best. Oh. Not really what I want to see. Okay. No error messages, no warning. Okay. We'll get the correct subdivision here though. I wonder. We have no data here. Hmm. Oh, yeah. We might want to fix this one. Stage Tessellation. Okay. I have nothing to go on here. We don't include this one at all. Get this. Do we need to define? Should be able to do it like this. Okay, here we go. And I guess it's these then. Okay. I would love to not be like, I don't want to have to define this compiler flag here as well. I thought by having this first, we would be getting this. But maybe. Because now we have some errors as well. That's good. We might have to do it like this. But if we do it like this... like this, make it a little bit clearer. Tiny bit. Then what do we have? Unrecognized identify vertex position inputs. Oh yeah, of course. Put these here. Interpolate by linear. So here we want to include some files as well. Maybe core. I hope. I'm pretty sure they handle their double include flags themselves, so shouldn't have a conflict. And util math, we should handle it here. Okay, good. Floor. No, did I? This one is weird. So we get the same. I want to open this one here. Okay, so for some reason we aren't able to use floor HLSL math age. I don't think it's this or this. We don't have floor anywhere here. Worried about this. Okay. Because we define them after. Just want to see if we get the same floor issue. Yeah, we do. Okay. I want to keep it like this. Problem is that if we have it like this, we're gonna redefine these, because we pretty much take this code and inject it here. That's 100% okay. So let's just remove these. Wait, that's beautiful, except for... Yeah, I wonder if we want to skip the default values here. So I think they are gonna override whatever we put here. We will experiment with that soon. Just this one boggles my mind. Floor, no matching one parameter intrinsic function. Possible intrinsic functions are floor, and then they use... Their example is... it's probably this one that is the error then. This, yeah. Undeclared identifier mesh subquad diagonal. Do we use that one here? Yes, we do. Mesh subquad diagonal. So we need to have this one here as well. Still get that issue. Oh yeah, it might just be this, which kind of sucks, but... okay, it's not that. I'm wondering if we don't have a... if we don't recompile this in the correct way. Seem to be doing that. Okay, so we have this one here. We define it here. But of course we have this one. Okay, so if we always define it. Now, there we go. So we can't really do this. Is that the case? Yeah, because I'm tired. There we go. If not defined, we define it. Nearest point on quad with normal. Yeah, because we want to include Util math geometry. And then I wonder if we have the correct. Yes, we do. Mesh dimension. Yeah. I think we're gonna need mesh dimension and mesh resolution as well. Although I am a little bit... Mesh resolution, we use it here. Use step. No, we don't. Mesh resolution. Subquad size. Okay, great. What seems to be tessellating all right. My question that, oh, we can change these as well. So tessellation amount, how? So even though we define it here with a default value, this default value is overridden by properties. That's beautiful. That's exactly what I want. Mesh resolution. I don't know if this one changes anything right now. This one overrides. Because we don't define these again here, do we? No, we don't. Okay, that's great. So we define them here. Mesh subquad diagonal. In fact, we have two of these. Like this. Okay. And then if we do we enable geometry again. Great. Don't take height into account. I wonder if that is something left behind from... So if we go to Tessellation... Yeah, we just do XZ here, distance. Take height into account, and we don't get our we don't seem to be getting them here either way, so we should be getting seams here. Why is that? One oh two. Seam. Why are we losing information like that? That's not good. Compare tessellation exponent. They screwed up these as well, but we can double check them soon. Worried about our nice seams we had previously, before the split here. So this one. Seam. And then we get it, and we actually get it on this side. Ah. So it works the other way. Actually, we get it everywhere, don't we? Yeah, we do. This one we probably don't use. I wonder if it's... Oh, is it... Did I screw it up here? No, I don't think so. 16. Steam just take factors, so it should be Tessellation exponent. This mesh subquad diagonal makes me wonder. Mesh subquad diagonal, it shouldn't be a float. It's a float. Oh, yeah. Could it be this one? No, it shouldn't be this one. UV step. Oh, UV scale. It might actually be... Nah, we just use it for normal calculations, okay. Okay, then I want to try and do... And now we get seams everywhere. It's just compare. It's the comparison that doesn't return the correct value. This one. Tessellation 0132. All of these. And then we do offset, and here we have subquad size, we do mesh dimension divided by mesh resolution. Could it be offset Mesh dimension, mesh resolution. 100 divided by 425. Good morning, PG King. Bum, ba-da-bum, ba-da-bum, ba-da-bum. This we want to fix to use the world normal as well, I think. Oh, could it be? No. Although I am a bit scared that, okay, what do we have? Dimension and resolution. Oh, I know. Well, maybe. Let's try and do a restart here. We need this one. So, yeah, otherwise we get seams. So it's kind of frustrating that it got removed for some reason. This one as well. Output seam. Yeah, let's do it. Return input dot seam. Yeah, we don't get any seams here, so The weird part is that we know that this one works the other way around. Do we get... Oh, could it be... Could it actually be... Calculate tessellation exponent. Ooh, yes. Maybe. No. We do. Is this really the correct comparison? Calculate tessellation exponent. If this one is bigger than this one. Shouldn't this one be like this? But if we do it like this, we get. And then we do it here. And here. Okay, I don't get this. We define a seam if we offset it. Then we compare this one with the neighbors. Could imagine this one not being calculated correctly being one problem. Mesh resolution and mesh dimension. But they look to be okay, I think. We get 25, that's okay. Mesh subquad diagonal, that's good. Pretty sure it's supposed to be this. Sad. Round. Don't do round here. And everything else works like it should. Love to print this, but we're gonna have to print it as 1 divided by maybe. Hate that we had it working before, or I'm pretty sure it was working before. So it's pretty much like this. We calculate the tessellation exponent for this quad, and then we send it in when we want to compare them. And we send in points but offsetted by subquad size. Depends on if this one is calculated correctly, but I think it is. Subquad size. It could be mesh dimension. Mesh dimension. Could it be that we truncate it? I don't think so. No. Yeah, this one should be like this. We're trying to look at this issue from the side of the one. So it's this one we check. We calculate the tessellation exponent for this one, and then we check the neighbor. If the neighbor has a bigger tessellation exponent, then this one should have a seam. So yeah, it should definitely be like this. But even with that, this one correct, we still don't get the right answer. I'm wondering about this subquad size. Mesh dimension, so let's replace this one by 100, and mesh resolution is 4. Okay, then we get it. Okay, so we don't send in these the correct way. Mesh dimension, mesh resolution. Mesh resolution, mesh dimension. If not defined. Mesh resolution. Mesh resolution, mesh dimension. Both are 4, however, we're gonna do it like this. Float 2, 2. There we have it. Float 2, float 2. Truncate here, whatever. We're gonna fix that eventually. We can do it like this. Okay, and then we don't need to output this anymore. Okay, so that's great. Okay, so now if we want to do tessellation on something, we just do... we just include this one, okay. And that's the first step, it's good. I just want to double check scale and offset. Test here. Do I want to have it here? No, I don't think so. I screwed these up a tiny bit. Actually, here we have the default values we want to have. 1, 0.5, and test I don't care about. 1 and 0.5. Is that actually correct though? Let's do... return. I want to return this. Turn sample level. $. Care about the height right now, so let's put it at 0. How high resolution texture did I actually do here? We do subdivision 4. Is it hard coded? If it is, yeah, texture size, we do it like this. Yeah, let's wait with this one. We're gonna double check it when we implement the new terrain ground shader, I reckon. So let's take a look at this one again. I wanna split off domain shader as well. I just wonder what we're gonna do with height map. Stage geometry default. Now we calculate the normal down here. I wonder per pixel, it's a little bit... Yeah, if we want to render our terrain from very far away eventually, we're probably gonna have to find some middle ground. So if we do normal in the pixel shader, we get... Let's return normal. Can I do... I mean, we end up with around 200. I just want to see... It's quite of a heavy calculation. Normal VS. Okay, let's do this then. It's not really that big of a difference. And if we skip geometry shader, okay. But I think, I wonder. If I want to skip domain shader output, I wonder if I want to skip this one. And this one. The color. U direction, however, yeah, there's no reason to skip that one. Or there's really no reason to calculate it for every pixel. We can interpolate it. Something like this. Normal interpolated here. Now we don't care about normal here. UV, I'm gonna skip color as well. UV seam, position, world space, clip space, and view direction. The normal here, we want to keep the normal in world space because we need to figure out if we're gonna cull it based on its initial normal. So that's okay. But we don't need to send it out from this one, I reckon. Domain. We take hull shader control point output. Skip this one. If we want to do some nicer tessellation later on, I don't know about that though. So let's see. Hull shader control point output. Ah, fuck, do we need the normal here? use it here, but that's vertex shader output. Still color it here, that's good. We don't do it based on height. Just want to fix this real quick. So in here, I think we want to reintroduce the Y. If we reintroduce the height, yeah, we get like this. This is nice. Hey, beautiful. Beautiful, beautiful. Let's commit this before I continue the destruction. Yo, what's up, Yash? Your work is great, dude. Thank you, appreciate it. Keep it up. Yes, I will. As long as I live. Is that a promise I want to make? Probably. Okay, I want to look into... We're going to commit this first, but after the commit, I want to look into... I want to look into being able to include this one. Yash, how much AI do you use overall in your process? Honestly, I'm a little bit of a slow starter in that regard. I have been using it a tiny bit. I'm gonna try to work it into my process a bit more, but like so a couple of weeks back we were fighting with Tessellation, the very same thing we're trying to just clean up now, and I hit pretty much a dead end and I tried to use AI for that. Unfortunately, it turned out to be a little bit too complicated for the AI. It gave me the wrong answers. So, but then we used it for... I used it for... Do we have this one? So when we were gonna do simple geometry stuff like this, getting a point, nearest point on quad with another point, then I used it. It was very good. And I have been thinking about... So to answer your question in short, I'm probably gonna try to use it a bit more on the parts that are my weak points, so to speak. So the budget for this game is pretty much 0. And my weak points are like texture generation. I'm gonna look into it for that, see if I can utilize it. But yeah, that's pretty much it so far. Right now I don't use it too much. I don't think it doesn't give me correct answers for very complicated stuff. I do use it as well. On the side I develop some inputs for my stream and stuff like that. And I've been using AI quite a lot there because my experience with web development stuff is I don't have that much experience with it. So when I use the AI together with web development stuff, it has been very great. Using it too much just takes away from the learning. Yeah, I'm a little bit scared of, like, when we talk generative AIs like textures and images and stuff like that, if we take texture generation, so this game is going to feature a lot of textures, different textures, so I pretty much have two choices. I'm going to have to learn Substance Painter or whatever, or maybe rely a bit more on AI. The downside with relying more on AI, if I don't get the correct texture from the AI, I have no idea how to tune it, because I haven't learned anything about substance painting and stuff like that. But we're gonna figure it out. Yeah, it's incredibly exciting, AI, but also a little bit scary. There's a fine line, I think. I'm just gonna have to find it and try and walk it. Okay, so let's commit. Let's commit our stage tessellation.hlsl. I'm gonna commit. I am gonna commit. Actually, I want some default values here as well. First of all, 1. And for both of these, we can take 1 and 1. So I'm going to commit this one and this one real quick. Let's just find the corresponding issue. So when it comes to this file, I would say that we're pretty much done with this issue. So I think we can close this one again. Fuck, haven't I added util geometry? Where do we have it? There we go. I thought I had this one. I still need to do, but whatever. Yo, what's up, Spires? Thank you for the raid, appreciate it. And welcome to all the new viewers. We're applying tessellation here, so for the last couple of weeks, 3 weeks maybe, I've tried to implement a tessellation solution for my project that will work for a lot of different stuff. And I think we have finally arrived at something that is performant and gives us the perfect, or the visual clarity we want. So right now I'm just in the phase, like, I'm trying to apply this tessellation shader to all of my different shaders that in one way or another depends on tessellation. Okay, we can't close this issue just yet because I need to do this still, and I think util math I'm wondering if this one is... I wonder if we have... let's just go through these methods and see which one we could define as a geometry shader and which one we couldn't. Yash, what do you need a tessellation shader for though? We're gonna use it for like our terrain, snow, water and stuff like that. And so when we're far away from the terrain, we will render it with few vertices, and when we're very close to it, we will render it with the maximum amount of vertices. I haven't really decided on the how big of a terrain we're gonna use in this game. But it's probably gonna be, like, best case scenario, 1,000 times 1,000 meters. And all of that, so 1 square kilometer. Or that is not true. But anyway, all of that, that full patch is gonna be fully terraformable and stuff like that. So if the player runs to one corner of the garden, is what I refer to it as, and look at the opposite corner of the garden, the opposite corner, if it's visible, maybe we have a high mountain, it will be rendered with very, very few vertices. We're probably gonna... we might not be done with tessellation now when I think about it. Because you might want to tessellate it based on rate of change as well. But that's a future me problem. So anyway, util math. Within bounds, that one feels geometric. Remap by bounds, nah. Min, max, average, not geometry. Truncate, no. Signed angle, probably. This one as well. This one as well. Inverse lerp, no. Interpolate by linear, Tangent by normal, I don't know. Geometry might be a bad name as well. The thought or the idea behind this one was that it's a lot of these things. Nearest point on line, nearest point on line, nearest point on quad. Maybe I should just close it. And okay, I'm not gonna close it. We're gonna leave it open. But we're gonna leave it to future me as well. Let me just commit first utility math geometry. Two files. Util math geometry. 149. Okay, and then we have this one as well. This one we're gonna close with this, I'm pretty sure. Yeah. So did I call this one? I called it stage tessellation. And it resolves 56. There we go. Okay. So let's think about we can start with the domain shader. Domain. Best case scenario, we would have stage domain HLSL, but we are gonna do a lot of custom stuff in here, I think. We can have stage domain default, which will do this. So we would have to define a texture and a sampler. And also the texture size. That's pretty much all we do here, right? So, if we take a look at terrain procedural water, fucking hell, actually. Vertex shader for this one. This one is interesting. Vertex shader output. We need a lot of things for this one. But do we really? Let's see. Position world space. This one we get here. Position screen space we can calculate in the fragment shader pretty easily. I think we can derive it from clip space. Should be pretty straightforward. Position in view space. Now think about this one. Normal, tangent by tangent, and normal in view space. All of these are something we're going to calculate in the fragment shader, because yeah, that's going to give us the best result, I'm pretty sure. View direction. One sec. What's up, Push Toy? Didn't I do... Domain shader? Yeah, we get this in domain shader UV. Fog factor. Compute fog factor. We do it by... This is probably something we want to do in the fragment shader eventually. Anyway. When we have a lot of displacement in the previous shaders, we're probably gonna have to rely on making this in the fragment shader. Okay, should be okay for that one. So actually, and then we have grass. I need to check this one as well. Okay. It's okay. For sure, that's a lot of shaders. Yeah. I've been in shader land for quite a while now. But the current thing we're working on, just updating most of our shaders to use our custom tessellation solution. After that, we're gonna move away from shaders for a while, do some game logic implementation. But yeah, we're doing a lot of stylized stuff, so yeah, gonna have to go with custom shaders. So if we take a look at the domain shader, this default behavior we have right here is one sec though. UV scale, UV offset, and UV step, they are dependent on this one, offset, what do we have? Yeah, this one. So they all depend on properties we send down from the CPU. So UV scale, UV offset, and UV step, we probably want to add these as properties, send them down when we create or when we instantiate the material, so we don't need to do these calculations every frame for every vertex and every shader, or every fragment, I mean. Is this something I want to do now? Let's see. Shouldn't we be able to do get texture resolution, HLSL, get dimensions, any texture object, so texture 2D. Yeah, I wonder. Okay, we do in and out. Would love not having to calculate this on a CPU, but I wonder. Even though we use this one, we're still gonna do a lot of these calculations. We might as well. UV scale, UV offset, UV step. Fuck, we do it in the geometry shader as well. That's a lot of calculations we can get rid of, I reckon. So what I want to do is mesh properties. I wonder, because the fact is, I would love to be able to rely on my Shady Utils terrain data. So it's actually these that should have all of this stuff. We want to get this data from here. Okay. We still do water as structured buffer. I'm not too sure about that. Yeah, if we do it as structured buffer, how do we want to handle that? That's a... Okay, I think we're gonna do it like this. We are gonna... In each of these, we're gonna add these. These properties, and for terrain data we just do, before we do get index from data here, we transform it, so to speak. So let's start with activity data. We have the texture, we have two samplers, and we have terrain activity data size. And I want to name them UV, scale UV, offset UV, and then step as well. We don't need to send in scale, that's true. We don't need to send in offset. Or actually, UV scale, UV offset, UV step. Let's do them as float 2 as well, all of them. Scale, offset, step. Would like to name them like this. Yeah, let's do it. So anytime we're gonna use UV here, we want to scale it. Actually, we have rescale UV. We do something. Util terrain data, rescale UV. Yeah, this one we want to... It's... UV size, we don't have offset here. Yeah, I wanna so UV size, float to scale, float to offset. We don't need to send in step. And then we want to do something like so we want to return UV times UV scale, but just scale, plus offset. We don't need to send in the size anymore. Let's do it like this. Maybe we don't need to send this one down either. We'll see. So for scale UV, instead we send in UV scale. Let's do it like this. Scale and offset. Do we have step anywhere? No. So let's copy these and here as well. UV Now we have the water data here. here we do get index from UV, and we want to do can we do this for scale UV grain scale, do it like this. Oh fuck, do we scale it here as well? Size, we do need size here, that's true. Should be okay. Uint index, scale UV, and something like this. Okay. So this means terrain tessellation shader. That means that we need to send this down. Let's see here. So we need to do something like, we have test quad here. When we set a lot of different stuff here, we do height map size. So we also need to send in these three. Scale offset, what was it? Scale offset test, and we're gonna name them. This is just our tessellation. This one doesn't use these, so let's create some temporary here. Float 2 UV scale, float 2 UV offset, and UV step. I don't really care about them being visible here. So scale, so we want to replace these. Before we do that, I want to send them down to make sure that we get the correct. So material set vector UV scale, UV offset, UV step. So UV scale, we have scale here, which we set to, we have them here actually, so 1. But I'm wondering if that is correct. We're gonna experiment with these a lot eventually. clip splice. So this one is just one. So -1. Let's take this calculation and put it here. New vector 2. And we want something like this. So texture size. So in this case, we're working with a square texture. That might not always be the case. But texture size minus 1. Divided by texture size. Yeah, and then we want to do the exact same thing for Y right now. That's it for UV scale. New vector 2. Offset, which we set to 0.5. So it's going to be 0.5. Times divided by texture size. Okay. And then finally UV step. Here we do use UV scale times this one. I wonder if I just want to do a ugly thing here. Yeah, we might as well. It's temporary, so why not? Let's do material dot get vector. Actually, let's do it like this. New vector 2. Times like that. So we're gonna move eventually all of this code. The setting of these is gonna be handled by terrain data containers. I'm pretty sure. But okay, something like this. That means that we now have UV scale, UV offset, UV step. Let's remove these. Let's remove these. Now we have a lot of errors here. So let's do this. UV scale, we have it here and here. So UV scale, UV offset. So we remove all of these calculations. And then if we move down to our geometry shader, we have it here again. But I wonder, we only use UV step. So let's remove that and do... We don't use C anymore, or do we? Yeah, okay, we do. Something like that. And then in the fragment shader, we do UV scale, UV step. We only use UV step. We use it in 2 places actually. Okay, it's already way thinner. Let's see if we have any compiler errors. Rescale UV. Terrain activity data size. Here we want terrain water data size. Okay. So these things are not something that affects this. It's more when we render it with a texture. So let's restart this and see if our normals look all right. I don't know if it's anything else. Okay, nothing looks good. Yeah, we don't even get the correct offset like this. Okay. So this is a perfect time for, let's see, tessellation test. What this tells me is that we don't send these down the correct way. UV scale, UV offset, UV step, test quad. UV scale, we might be getting a integer here. An integer. I wonder if it's enough to do this. And I can currently see that we don't have any normals on this one. But which is weird. Our height works. 1 sec. Terrain tessellation. Normal. Because we returned this one. Okay, let's see if we do this then. Light. We have light from this. Yeah, it looks good. Okay, nice. So what we want to do then is finally we want to create stage domain.hlsl. Yeah, we're gonna assume that this is the naming convention we follow. Everything like this. Okay, beautiful. Get a utils stages. Let's duplicate this one. Stage domain. I want to rename this one. Stage domain default. I don't know if we need this. Guess we will find out. I don't think we need any of these, or we're gonna find out that as well. Vertex, we don't need any of these. Actually, I just want to take the rest of this and delete it. Okay. So we need to define domain shader output. But at this point, I'm pondering renaming this one to fragment shader input. I'm wondering, like, if we take a look at the geometry shader, so we could either go domain shader to fragment shader, or we could go geometry shader, fragment shader. Like, whatever sends data to the fragment shader, it could be various different stages. Yeah, so if we're gonna do this, let's just do it. And like, when we inject the geometry shader, it's like, I look at it a little bit like it's doing work where it doesn't belong really. So it injects itself between the domain and fragment shader, and the domain shader thought that it were gonna send its data to fragment shader, but instead the geometry shader takes it and just alters it a tiny bit, or spawns some additional data points. So yeah, let's do this. We call this one fragment shader input. And then we take the domain. Yeah, then again, I'm a little bit worried about these. Because sometimes we send in. Sometimes we send in terrain base data to get the height. Sometimes we will send in terrain water data to get. So yeah, I don't know. I don't know exactly how to handle this one. Yeah, maybe this is better as a method instead. So an inline function pretty much. That's probably what we want to do. Yo, PG King, my piano was getting tuned. Oh, nice, you have a piano. Thick. It's going pretty good. moving at an acceptable pace, cleaning up, modularizing. Yeah. Nothing too fun or revolutionary, but just works that needs to be done. Pretty much. Modularizing, what is that? I don't know if it's a... I just... Like when I do stuff on the CPU, I like to keep everything like in modules. Tiny building blocks, pretty much. I'm trying to do the same with shaders, but it's a little bit more complicated. We finally got a piano. It's pretty awesome to have a real piano at home. Yeah, I can imagine. Always been a dream of mine, actually. I mean, like best case scenario, I would like to have one of these, you know, fancy, I don't know what the English word are for them, but one of those fancy pianos. I have played very little in my young days. I played a lot of guitar, however. So I could play some piano as well, but I've always wanted my children to get into, like, if you're gonna play one instrument, I would think piano is the best one, but I wouldn't identify myself as a piano player. That's definitely the case. If I win the lottery, I'm definitely getting a fancy piano. I just need to check out what the English word are. Oh, is it just called grand piano in English? What a unfancy word for a fancy thing. Grand piano. Fuck, they are grand piano. They are fucking beautiful. Piano isn't that hard to get into, and it kind of goes with everything. Exactly. 100%. The feeling of playing on this, yeah, I can imagine, I can imagine. So, I don't think we can take this full stage and put it in here. Instead, we're gonna do some... So maybe I should rename this one again. Rename stage domain. Domain stage contents. Do I want to define this one here then? Yeah, probably do. So instead we're gonna have fragment shader input, calculate main shader output, default output. And then we need to send in a few things here. We're gonna send in this. I just have to double check inline HLSL. Okay, yeah. I thought it was something like that, so we don't need to specify inline, it's the default value. And then I want to send in, what more do we need here? Position UV, this one, yeah. UV, UV. We need to send in this one. So we're gonna send in... No, that's... We're gonna send in float... position offset VS. And that's pretty much it. And then what we're gonna do in here is we're gonna take all of this and put it in here. Interpolate by linear, so we are gonna need util math. Anything else? Sample, transform. No, I don't think so. So this is fragment shader input right now. UV. Yosa Blaze, what engine is this? Unity. Unity. Interpolate by linear. Output.uv. So then I wonder, we don't need to do this. So position UV, and then we're gonna read height. So actually, we're gonna do it like this, I think. We don't need to do it like this. Position VS. We are gonna add... Ooh, we need max height as well, that is true. So position of... Nah, we don't. So we just change this one to position offset world space multiplied with this one. Anything else? No. So I wonder, we can probably take this one and put it here. So position related UV seam. Blaze, yeah, I'm getting into game developing myself. Oh, nice. What engine? PG King, are you a dev professionally, by the way? Not at the moment. Going in, I'm thinking about maybe it's time soon to get back into it. Do some consultation work, you know. think this is how we want to do it here. I mean, it's not as clean as I would like it to be. But what you're gonna do? I'm gonna do... Yeah, so it's gonna be like this. Okay. On this one here, we're gonna do... Let's grab... where do we have it? Itemap sample. Come on. We do the UV scaling here. We want to do it here. Now we're gonna do it like... If it's a possibility and you'd enjoy it, that sounds awesome. Yeah, we'll see. We will see. My biggest... I wonder, like I still want to do this part-time-ish. And I wonder how overwork... Like, I'm one of those people. I'm having a real hard time letting go of work, so to speak. Like, when I quote-unquote clock out, I don't stop thinking about the problems and what I've done and such. And I just wonder how... if I would be able to handle having 2 or more dev projects in my mind at once. I don't know. Or actually, it would be definitely more than 2, but maybe it's worth a try. We'll see. Like maybe doing some shader work on the side. That's always nice. Depending on the shader work, it could also be a little bit relaxing. Okay, so here is the next problem. UV scale. We want to send on... we're gonna do it like this, actually. Okay, we have one problem here. No. We're gonna do it like this. Of course. Yeah, we're gonna make it a little bit more ugly, I reckon. Like... This one, the custom stuff we're gonna do here needs UV, and this one needs the custom stuff we're gonna do here. So the best... Like here we need something red from a... I think we're gonna do it like... Or actually, okay, we're gonna do it like this. Calculate domain shader. Interpolation output. So what we want to do here, what we want to offload from our shaders is pretty much this stuff. We're going to do this. We just interpolate position VS. And we interpolate UV as well. And we fix the seam. Everything else is going to be up for this one to do. So return output. So it's pretty much going to look like this. The first thing we do here is fragment shader input output is equal to calculate the main shader interpolation output, and we send in factors, patch, and UV tessellation. Really hoped we could have that on one line, but okay. And then here we do all the custom stuff we're gonna do. Eventually in our in our terrain shaders, which utilizes these files, we're gonna use this stuff. So this is just, we get custom structs here which are easy to use. These files are, their entire purpose is to export or translate data in a texture to actual data we can use. So it actually translates or unpacks one float value that actually describes a direction in 3 dimensions. But okay. So in our case here, we do float, Y position, offset, VS. And here we just want to sample. We just want to sample it like this. So first we're gonna do output.uv is equal to output uv times uv scale plus uv offset. Then we calculate y position offset world space, which is going to be height map sample. Care about level right now. Bilinear output.uv. I think that's all we need. And then we do output.position vs.y plus equals to y position offset vs. We could probably we need to do height, max height, output position cs is equal to, get this one, transform, something like this. I mean, it's not perfect, but it works. It leaves, we can do a lot of custom stuff here. That's nice. Still, whatever. So for the ground, this is all we're gonna do. For the water, this is probably everything we're gonna do. But for the snow, we're gonna do a lot of extra stuff here. What I wonder now, however, is the geometry shader. We're gonna check if this works. If it does, we're gonna move on to the geometry shader, see how we can split that up. We can probably move this into its own file and so on. But before we do that, I just need to run AFK for a couple of minutes. So be right back real quick. Okay, back. Sorry about that. Let's see. Let's see if this works. First of all, I just need to change these to fragment. Okay. Fragment shader input. Let's see what we have. Yeah, we need to include this one as well. Gonna include it. Stage domain. Really? Okay, 23 domain shader output, yes. Unexpected token output. No, we don't want to check that one here. Through in tessellation test 97. Yes. Six. What am I missing here? Y position offset float times sample. Do we have? Oh yeah. Sample level, because we are in the domain shader, not primate shader, and let's do level 0. I should definitely be able to do .y, I think. Okay. Yeah, let's see if this works still. Beautiful. Beautiful, beautiful. We get the tessellation as well. That's great. Oh, if we had the animation in place as well, it would look beautiful. Okay, let me just commit this real quick, and we can move on to the geometry shader. I wonder what we can do about this one. We're always going to create new points like this. We could define this method outside and just use it. But it's a little bit back and forth. That is probably okay. Because this part and this part is always gonna look the same. This one, however, might not. This one is actually gonna resemble this one quite a lot, except for the interpolation. So, ooh, yeah, the best case would probably be okay, I think we can hide. Ooh, before we commit this and move to the geometry shit, I'm gonna try some things. I think we can define, I think we can get around this by, we define a method here that interpolates points, and then we just utilize this one in here, maybe. Maybe. How would that look? So I'm thinking fragment shader input. Fragment shader input transform. Fragment shader input. Then inside of here, this would be so, if this works, then we can put all of this in here. That would be beautiful, I think. Fuck, we're gonna have to define these ones. Makes me wonder. Would love to have the pragma in here as well. But if we do include include. Have I changed anything to break this currently? No. Okay. And then if I do, we define this one here, but we also define it here. Should get a error, yes. Redefinition, but if we do if not defined transform, and we do it like this. No. But maybe see. We could do it with macro. I'm gonna double check these. Okay, so what we could do is that's not what I want. I have redefined, maybe not. If def. Oh, that's true. We have it here. Okay, can we do redefine? Define. Undefine. Beautiful. So we can just do this. We define a transform function here. But then we tell the compiler if this one is defined, we do undef. But then again, yeah, we probably still want this here. Something like this. Okay, that's great. So then we can probably also put this one back to where I want it. Transform function, might want to rename this one, but whatever. So the idea then is the default transform function is just gonna be actually, now when I think about it, we want to define this one as an in-out. In-out. Okay, so the default transform is gonna be just this. So basically, if we don't have a transform function defined, we just set position and view direction, because we don't do it down here. Then here we do. We want void here then. Transform might not be the best word, but okay. So the idea is that we will have a domain shader here, and it will use a transform method. Either the shader in question that implements or that uses tessellation defines its own transform function, or we just do the default value like this. So the transform here then would be we need UV here as well. We already have it, so that's okay. So for this one, it would just be this. And the best part, if this works, is that we can do this. So our domain stage is located in this file, but we can override-ish or redefine the transform method, which does the custom stuff after the domain interpolation. Maybe this would be pretty sick, because we're going to use something. We are going to use... Okay, I'm a little bit worried about this though. It's the center points. Works here, beautiful. The center points are offset the wrong way because we do. Could it be? Okay, I'm gonna check this works. So we do this, and now we use this one hopefully, so we will offset it by height. Hoped, but we don't. Okay, that's good to know. We include this whole file. We check if this one is not defined. Define it. And then we get to this one if we check, is this one defined? If so, undefine it, and then we define it again. But Do I screw up? Ooh. No, it should be okay. I don't know about this, but I wonder, like, it seems like this transform function that offsets it, it never gets called. We don't have any errors, do we? And we get the tessellation, it works. So the domain shader is being run. Take a look at dev. Create a region. What I find weird is that if we don't have this, we get a redefinition of transform. Okay. What am I missing? What if we do UV is equal to 0? Yeah. So it still uses this one. Yeah, so we just undefine this one. We don't undefine this one. That's a little bit weird. I think. Because we still don't get redefinition. Oh, one sec. Void. Redefinition of transform 85. But okay, so if we do a if defined here, shouldn't we go into this one? We should get the same issue. What the hell? So what happens if we remove? Okay, then we get that. So we can't use it to define blocks like this. We should be able to do something similar, I would guess. Just need to figure out what. I don't want to do it with macros. do it with include. Constant or a macro. Preprocessor directive that creates a function like macro. I don't want to do it with that. Definitely not. I mean, we could solve it by doing, if not def transform function, like this, but then we're gonna have to include this one after the fact. Sure, or I thought fragmentary. Yeah, we can't do that either because this one has this definition. But we can do it like this, and then we put this one. Maybe it's not such a bad idea to have it like this. So we tell the compiler that we define our own transform function, but include everything else. But then we use this one here. Oh, that's true. What the fuck? Let's see here. HLSL flag to include code block. We do it in another way. I really don't want to do this as a macro. Really, really don't. It all depends on Do I really care? What the fuck, we could do it like this probably, but it's... We're gonna have... I want to avoid... one sec, maybe. Yes, we can do it like this. The order is still gonna need to be this, but we take these two lines and we remove this, and at the end here we do if not defined transform function. Then we do this and an if. And here we do, is it just else? Else if, else and if. And we put this one here, and then we need to put this one here. Okay, let's see. We include the tessellation stages, and then we define a transform function. And then we include the domain shader. We include everything here, and in the domain stage, if a transform function hasn't been defined, we just take whatever we have and transform it to clip space and calculate view direction in world space. Otherwise, we use the transform function that is defined. But how tired am I? It still leaves out, like, this one needs to come before this one. This one needs to come after this one, and with this one needs to come after this one. We have a little bit of a circular dependency here. I don't see how we're gonna solve this this way. We can probably figure something else out. If this one takes fragment shader input, however, we could define it here. This one needs transform, and this one needs this. So whatever we do, this one needs to be defined before this one. Makes me wonder if tessellation test. No. Stage tessellation. I mean, one way to do it could be, and I'm thinking this might be a nice clean way to do it. It could be to split up the struct in question and the code. So include stage tessellation structs and stage domain structs. So I wonder if I want to do okay, that's the backup plan. Unless I can figure out a different way of doing this. I think there's no way around it that we need this one. Let's do then we would have to do And then we can do stage domain. So this one we can just leave it as it is. For this one we do... I mean, it looks a little bit weird, but stage is domain structs. Okay. So now we define our transform function ourselves. It sets the UV to 0, 0. We can choose to disable this one and just rely on whatever this one has. But yeah, we have input here. We want to change this one to output. Nice. So then if we include all the functionality with tessellation and domain shaders, but we still want to do some custom stuff in the domain shader, then we just define a transform function like this. Might want to rename the transform function eventually. And it's something very similar we're gonna have to do with the geometry shader as well, I reckon. But we will get to that. Let's see if this works and commit it. Beautiful. Beautiful. And let's be a little bit let's do it like this. Okay, so first of all, I'm just gonna commit. We're gonna commit stage tessellation because we split it up, and then we can commit this one as well. I just want to implement geometry. Tessellation 56, there we go. What is it called? Stage tessellation. Okay, and then we have main structs and domain. I also want to commit the tessellation or terrain tessellation test. Git add I'm actually gonna put these related to this one as well, even though it's closed. Okay, nice. Okay, final stage. I want to split up. So stage geometry. So, let's see. So then we have this method. So very similar to transform function. We're gonna have something like this for the geometry shader as well. Yeah, that's pretty much it. Fuck, this is gonna look real clean. So, like initially, this whole file, I don't know how long it was, probably. Can we check that, by the way? I just committed, but around 500 lines maybe. And I mean, that sucks in the case. So if we take the water shader, for instance, only the fragment shader in the water shader is more than 500 lines. So if we would add tessellation to the water shader as well, we would be looking at over 1,000 lines. And I want to keep them short and nice and tight, and that doesn't even describe the biggest problem. So like if each shader would implement this tessellation shader solution themselves, if we wanted to update the tessellation solution, which we're gonna do, because there's one thing or two things still I want to improve upon it, that would mean that we would have to jump in and edit so many files. Now instead we just edit it here and we're done. But create point from, so basically what we do here is we just we want to create a new point given these 2 points. The default is just to create it by interpolating it. Probably gonna do, we can, I think we can do this real nice. Yeah, we can. First of all, let's start by defining our geometry shader, or stage geometry, HLSL. Which one was this one? We don't need structs here because we actually use the domain one, so we're gonna do stage geometry. don't know. Maybe we can remove this one. But, and then we're gonna do this. If domain structs are included, then if not, define this, because we use the same here. So we could actually do, we could do geometry shader without having a domain shader eventually. But okay, let's see. I want to take this one. And put it here. We have UV step here, however. That should be fine. Actually, it should be extremely fine because we don't even use it with the current solution. This one is something we want here as well. Okay, and then we have this one we need to take care of. We are gonna call it... Actually, let's start by defining... Ooh, this might be... Let's see how I want to do this. Create point from. We are gonna do... Create point from. Yeah, I think we're gonna do it like this, actually. The best thing with this, I think, is that when we create new points here, we're probably always gonna do it with the help of this one, I think. So I think we can do this. Actually, let's take this one and put it here. So create point from, we get 2 points, we create one new output. UV lerp, 0.5, seam like this, position interpolated VS. I think we're gonna do this. Output dot position VS. Yo, what's up, Fabic? And then I think we're gonna do... Do we only have 5 outputs we want here? Yes. And I think we're gonna do this here. If not defined, transform function, so the same. Then we do this, else we do something else. Yeah, it's a little bit late. I think we're doing fine, so let me just summarize it real quick. For the past weeks, we have been experimenting a lot and fighting a lot with tessellation, and we finally have an acceptable tessellation solution. This tessellation solution is going to be used by a lot of different shaders, but mainly ground, water, snow. So right now what we're in the process of doing is taking that tessellation implementation, splitting it up into includable files, and then include those into our shaders. Just making it nice, and so that all of the different shaders uses the same implementation. And yeah, we're moving at an acceptable pace. Thank you for asking. How are you doing? Any progress on the volumetric lights? So what I'm doing here is we create a new point, interpolate it in the middle. If Jesus, Fabic, thank you so much for the donation. Appreciate it. Just need a few seconds to land. Thank you so much. I really, really appreciate it. Big shaders are off the table for now. Just shoot me a message if you need any help, and I will do my best to answer it. Okay, so what I'm thinking about doing here is I'm gonna use, like, basically we create a new point here between 2 points, and we want to interpolate, or it's going to have a finalized position and it's going to have a interpolated position, and then eventually we want to interpolate these in a nice way. But the final positions are going to have the exact same we're gonna make them in the exact same way as this, so I think we can do this. Let's see here. Yeah, I think we're gonna do fragment. Actually, output, yeah, fragment shader input final is going to be equal to, first of all, we're going to set it to output, and it's a struct. We copy it, I think, and then what we're going to do is we're going to call transform on final. So what we do then is which makes me wonder if we want to do this for all of them. Or actually, for now, we can just do this, I think. Transform output. And then I'm gonna add interpolation between interpolated point and a final point. Yeah, I think this is what we want to do. So, like when we work with shaders, shaders that is going to displace vertices and tessellate, then we just include the files and define a transform function if we want. We don't need to define this one. But this one is actually the one displacing, so if we want to displace, we better do it. And we're gonna do this, and then we're gonna do like that, and then I think we're done. Let's see if it works. No compiler errors, at least. Yeah, one thing I need to fix as well. We also need to define this one. I would love to be able to have these in the include files. Maybe we can. I'm gonna double check if that's possible. Okay, we have a little bit of an issue here. Yes, of course, I know why. So our middle points, they get double the offset, and we want to avoid that, right? The reason they get double the offset is because of how we do the transform here. We do... Okay, so this is... Wonder how I want to solve this. So when we create the middle points, the height is interpolated. Well, you can probably do this actually. But then again, if we transform this plane, so when we calculate the middle points, we have two other points. They are already displaced on the y-axis. So when we interpolate between those, we get a few, or we get a height as well. And here we just add a height. We could just set this or remove the plus sign, but then we make the assumption that the plane is located at 0 height in world space, and that's not really an assumption I want to make. I want this to work for a plane even though we offset it and move it around and do all sorts of things with it. So we need to handle this here in some way. The position, so we would like the original position. Oh, this tessellation test shader is so short and concise right now. It's pretty much just a transform function and fragment shaders. Pretty cool. Cool. But okay, create point from. We could do it like this, although okay, basically what we have this, let me draw real quick. Could probably help me arrive at a solution. So what we have is round, and then let's not say round actually. So this is our mesh. It's located somewhere in world space. In the domain shader we offset these points. Maybe we offset this one here and this one here. And the error we do right now is that when we add a middle point, we take this point and we interpolate between them in the middle of them. So here is our new point. Then we take this point and we read from the height texture, and then we add that height as well, which means that we end up with a point up here. We would need to negate the offset of the other 2 points. We don't want to send down more data throughout the pipeline. So, because otherwise we could just add original position, and then we would get this point and then we offset it. I don't know if it's possible to track here, however, without doing that. We could read neighboring textures, but that's 2 texture reads. I don't want to do that. I don't think there's any way to get to this height, is there? We could probably use we could probably use something here, but that's a matrix multiplication. I'm not sure I want to do that either. So we could do we could do world to object. So we transform it to object space, set the height to 0, then offset the height, and then transform it back. But then we make the assumption that the height is at 0 in object space. And I mean, that's a better assumption to make than that it's 0 in world space. But it's still not... It's not perfect. But. Actually, I think we can do this. Shouldn't we be able to do... Yeah. We should be able to take this height. Yeah. We should be able to... So we get a height here. Let's do height interpolated. And then we read the height from the texture. And then we just do... what is it? Height, texture... minus height interpolated. So if it should be located here, then we just offset it with this. Yeah, that should be easy. If it should be here, this one is smaller than this. Yeah, something like that. We should be able to just do... But then again, we transform... We could do... Yo, what's up, Cynic? We don't want to change anything here. We transform it. We do this. Float. Height interpolated equal to output dot position vs. We store this one and then we do output. What sucks with this, however... Fuck, am I might be... Yeah, this is way easier than I thought. Okay, I'm starting to become tired. I think we can do just output position vs. Dot y. Cynic shaded code always make my brain hurt. I know exactly what you mean. Relatable. Shouldn't this work? If we set it to negative height interpolated and then we add height texture. No, because this is not height. This is actually world position. So that means if this one hole was offsetted, yeah, it would break. The Fabric have to go, sir. Wish you all the best and hopefully I can catch the whole stream tomorrow. Keep up the great work you're doing. Thank you, appreciate it. And thank you once again for the donation. Very much appreciated. Have a great one. Assuming I've never really grasped it either. Tried so many times, but it's just too much math. Yeah, like... I learned shader programming through 2 courses on the university, and I had this mentality, like if I enrolled, I at least needed to complete the course. So at some point I didn't really have a choice. And just grinding through the first threshold eventually made me understand it better. And then it's just a lot of grinding. Yeah, it's definitely a lot of math, but the hardest part for me was to grasp the concept of like it was threading, or pretty much when you write code for the GPU, it's basically threading, but way bigger, if you know what I mean. So you always have to keep this parallel thinking in mind, and that was the hardest concept for me to grasp, I think. Cynic math made me quit uni and I got a job, so took the chance. That's also relatable. Yeah, so if we want to keep this object, if we don't want to work with absolute values, we probably need to add some more data to make this work, fortunately. We had this problem previously to splitting up everything in different files. It's just that I postponed that problem to future me. And yeah, we're at future me right now, and I don't enjoy it. But it shouldn't be... Oh, can I do a hack? Like, the last thing I want to do is add more information here. If we add more information to these different structs, yeah, we're gonna require more memory. Yeah, it's just gonna reduce the performance overall. I'm starting to think that the best option might actually be to utilize this. So still You know, fuck it. We're gonna do this. We're gonna do this for now. Because I'm just gonna postpone it even further into the future. Because I don't know how I eventually want to handle this. We're gonna find out when we add the tessellation to all of these shaders. But like the terrain, it has a minimum height value and a maximum height value, and that is like set in stone. It doesn't really matter where the terrain object is located in world, it can never go beyond or below that range. And when we read, for instance, the terrain base data and we get height here, that's going to be a value between 0 and 1 related to that or normalized by that range. So I might be a little bit bold by doing this, but I think it's okay. So that leaves us with this. And that is beautiful. That is beautiful. It's fucking great. Okay. Oops, I see something I don't like. Over here, I see a little bit of a seam. That's not good at all. Yeah, I love the color gradient you get from UVs as well. I see a little bit of a seam over here, and that sucks. I wonder why. That's weird as hell. Or actually, I know why, I think. So we have the seam here. It could be, I think, why are we getting this one again? I wonder if it's because of our UV scale and UV offset. Nah. We can see here that we always, the topology always matches 1-to-1. It's not a topology problem, this seam. It's a height value problem. And I wonder if it's because, or if it's because we take, we're just gonna double check this. Tessellation, oh, that's not the one. Stage tessellation. I'm wondering if that's because we take Y into account. Maybe. Nope. Cynic need to head out. Thank you for stopping by. Always appreciated. And good luck with all the stuff. Yeah, it's something wrong with the height offset. Look at this. So why do we get it again? That makes no sense. Whoa, 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 whoa. Am I seeing this correct? Yeah, okay, so it definitely has to do with the middle points. But why? Transform. If not def, transform view direction. So then we just do this one. Oh, yes, it's this one. Oh, we transform the UVs twice by utilizing this transform again. That explains it. Ooh, okay. How can we get around this one? That is the question. We could. We could do this. No, that's not true. I know. We can probably do it like this. No, did I remove stage tessellation structs? No, domain shader structs. Okay, so what we're gonna do is I mean, we could do this. This is probably the easiest way to do it, I reckon. Transform, bool, scale, or transform UV. Because the thing is, when we go from the domain shader, when we transform here, then we want to transform the UVs through. When we go from the geometry shader, we don't want to scale them again. But yeah, this muddies the waters a little bit, but if transform UV, we do this. And hopefully that should be it. If it's not this little icon here scared me. Pretty sure this is it. Yeah. Beautiful. Look at this. If we can feed it some customized MIP maps as well. Damn. Okay, that looks great. I think this is a good middle ground on the solution. I'm gonna commit this, and then I just want to experiment a tiny bit with having these in their respective files. And yeah, if we could move these, that would be very nice. Maybe if we could do something with these as well. And then I don't think we can remove much more from this shade. Look at this, it's not even 150 lines, and it got it all, almost. Okay. Let's commit this real quick to this one. Yeah. Stage geometry, stage domain, terrain tessellation test, yes. And we added stage geometry. Related to 56. Beautiful. Okay. So let's take a look at these. Pragma, pragma, pragma. Mm-hmm. What the fuck? Nothing in the documentation here tells me that we shouldn't be able to use these. Or that we should be able to define them down here. These. Because if we take a look at what comes after, we include my custom files, we include this stuff, or we define these properties, variables, and then we include this one. So why? Let's see here, stage tessellation. Maybe. Okay, let's try it. So stage tessellation, this one includes vertex, hull. Vertex and hull. See what we get. Yeah. This makes no sense to me. Or is it that when we define fragment, vertex needs to be defined before? Could it be? Okay, that's not it. See what the internet says about it. Actually, we're gonna do it like this. One sec. Let me see if I can find a specific file. Where do we have it? Library maybe, package cache, rendering, render pipeline core. Let's take a look here. Outlines. Outline supply, blitz shader, util blend. Here we do shader library, so it's universal. But we do define our vertex and vert here. I still want to check this one out. Universal shader library and no. Pipeline core, runtime, utilities, lit. Let's open it here. Do we have any pragma here? Attributes, bearings, vert quad. No, okay. So they just defined this one. Pragma needs to be the main file. Oh, yeah, I think it's my lack of knowledge here that screws it up for me. My guess is that this possibly needs to be located in a .shader file. Maybe. I don't want to read more about it right now. So let's just keep it here. I'm happy. I mean, it's just a couple of lines at best. Let's see. Yeah, I actually think this looks great. So, what we're gonna do now is I'm gonna create a new shader. It's I'll probably just name it Tessellation template shader. And then we're gonna take that Tessellation template shader and we're gonna create a terrain ground shader. And then we're gonna take that template and create a terrain grass shader. We're probably gonna take most from this. But that actually makes me think of one thing. In procedural grass, okay, this might screw it up. We can see what we do about it. I don't want to open it here. I want to open it here. Where do we have it? Procedural grass. Yeah, we need to output a lot of more things from the geometry shader, but that's not all. Our geometry shader is doing crazy stuff. So we do a lot of things in the geometry shader here. I need to figure out how I want to handle this. So like basically, I want to do this stuff. I want to create these triangles. And then I want to call something here. So we're probably going to do something similar to we do with this transform function. Everything we do here is probably going to be some sort of function. I don't know, grass function or something like that, or triangle append function. And for each triangle here, we're just gonna append. Yeah, we're gonna have to fix this one as well. This one is gonna be defined by something, but that's okay. That we can fix pretty easily. Yeah, I think they're okay. The grass shader is probably going to be the most complicated to transform into our new system, but I still think it will be quite doable. The ground shader will definitely be the easiest one. I mean, look at this. 735 lines. I just want to keep this one. I want to see where we end up eventually. Because in this one we define a lot of, like, this is a lot of lines. This is just duplication of our tessellation include file. This is just duplication of our domain. Yeah. Okay. Let's create a terrain template shader. I think that's good. Actually, let's duplicate terrain tessellation test. And let's name it terrain template. A template, I say. So it's just gonna be a starting point for all of our terrain shaders that is going to utilize the tessellation. This will be the starting point, and then we add all the custom stuff to it. So what do we need in our template? We don't need color, mesh dimension, we need mesh dimension. We need mesh resolution. And we need mesh. All of these are actually... I think they're related to tessellation, so we can keep this one here. And I wonder if we eventually want to hide this. Maybe we do. We need this, opaque universal pipeline, callback LOD 100. Yes. Honestly, I don't think we need all of this. Lighting. Let's see what we're missing eventually. The form, we're not going to have any deform. UV step, UV offset, UV scale. Best. Include the tessellation stage. One sec, did I fuck up? No. Include tessellation stage, then domain structs, or stage domain structs. Transform function, we're not gonna have a transform function here, but it's a template. So let's keep it. We can do this. I don't care about this. So we just do this here. Then we do the domain, geometry, normal vs. Color. Should be we're gonna do some renaming as well, but so I need lighting, and then we do environment, terrain, template. Then we do no, do we actually need these here? Yeah, we do. One sec. Yeah, fuck it. And then I want to just check so we get the correct stuff here. So environment materials, terrain tessellation test. Let's duplicate this one. Terrain template material. And then we do quad, terrain template material. Let's play. There we have it. Okay, let's commit this one real quick. Shader. I think we're gonna put this one related to this one as well. There we have it. Hopefully the last commit here. Hopefully. But I also thought this one would be it. Okay. Yeah, I think we have time to do the new... terrain ground material today as well. Hell yeah. One sec though. Or actually, give me 1 minute. Be right back real quick. Okay, back. Let's see what we can do. Yeah, so what I want from the ground material right now is, of course, I want it to tessellate exactly like we have implemented, but I also want to be able to, I want to calculate, it's going to offset its height based on a texture it's being fed, and it's going to be terrain base data. So I want it to rely on this one. I want to properly light it. Want to add some light options as well. How much ambient light and things like that. And eventually we're gonna have some texture blending on it. We're gonna make it look real nice, small pebbles and whatnot, but not at this point. So what I want, I want to be able to decide it's just a plain color for it, maybe normal map, just a plain color, and then we're gonna add a very nice grid visual to it as well. So it's gonna be quite similar to what we had previously, just better topology, better lighting, and better grid as well. So let's see if I can show you what we have currently. How it looks currently. Not a big fan of it at all. We have a few different grid lines on it, but we're gonna get rid of them all. If we don't crash, that is. Yeah. Terrain patch. Where do we have my terrain patch? Yes, okay, I know what's wrong. So the material right now relies on the mesh being a triangle, but we're currently creating it as a quad. I wonder if we can easily... I also want to remove this one. I wonder if we can fix it easily by going to terrain base. Terrain base. And when we create our base mesh here, we do triangles. And also, I noticed that when we create the terrain patches, we instantiate, we never set the parent here. Okay, we're getting closer, I assume, or I guess. Rain patch. Is it because we don't have any material on it? Okay. Mesh renderer. So let's see if we can... We won't have the correct data in it anyway. Ah, well. It's visible on the VODs how it looks. Well, maybe if I do environment, materials, terrain, procedural, grass, terrain, material. Then we have it with the grass. Can I do... Now we're still gonna get... Okay. Fuck it. Let's just create a new brown material. So I'm gonna switch this one back to quad. Okay. And then we do Terrain template. What's the meaning with having a template file if you don't use it? So let's duplicate it. And we name it ground. We need all of these. We're gonna rename it here. Terrain ground. Round. Round. Okay. So we're gonna start with the offset. i.e. we're gonna use terrain base data. So we just need to include this one, this file, and then we should be able to get what we want with these methods, given that these are being set. So before we continue with that, I just want to make sure that we have a way of doing this. So I want to jump to my terrain data container. Set as render target, value normalized. Set material reference. Shader property name. Okay. I want to set way more things here than this. And I want to set it based on terrain data, shader property name, UV scale. Oh, one sec. Terrain based data. We have it here. UV scale, UV offset, terrain based data. This is perfect. This is how we set these. So my next question is, do I want this one to like best case scenario, what I would like here is I send down a material, or I give the container a material, and the container sets all the properties in that material that it has. But to be able to do that, we need to figure out, or I need to figure out, if data containers should know the data type they have. Probably yes. Or actually, maybe not. No, maybe not. So basically what I'm getting at is I'm trying to figure out which who I want to be, which class should handle this, but more specifically then. I probably want it in these three should be set when we create the mesh. So this will be terrain base. For show. And this will be when we create the material, and that's each terrain patch. So set material, terrain data types dependency. So it's pretty much this. Set material. Do we have other stuff related to material here? Set data reference in material. No, fuck this. Ugh. We do set material. Weather effects. We're gonna rework this one now. It's gonna be way nicer. So I think we can probably get rid of this one. Now we have debug material. Yeah. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all of them. Set layer. Layer. This, I'm pretty sure I don't want to do this. Yeah, we don't want to do apply or clear within these methods. So what I want to do, and the thing also is that we're gonna add multiple materials to this mesh renderer. So but yeah, I want to avoid this shit as well. Okay. So we're gonna have to do... We're gonna have to add logic here. It should know which type it has. Value index. Yeah, so probably what I want is... data string, terrain data type, data string, data float value type, data float value, and then we do type micro index here. Yes, what I think I want to do is data container. We are gonna do... I'm gonna send in the types here as well, I reckon. Actually, I don't think we need to do that, do we? It would be very nice if we could do it. Yeah, I think we're gonna do it like this. Height, foliage, water, activity. Said this multiple times. I want to fix this one. I have something in mind, but we're not going to do it for a while. It's boring back-end stuff. But I think we're going to say macro index, macro type. Yeah, I think we're going to have to do this. Public, rain, data, type, macro, type. But let's make it get private set. Where do we have our constructor? We have it down here. And here. Okay, let's do buffer container. So actually protected set. Something like that, and we have a few errors here, so let's do rain. Oops. Dot something. So for this one, height. For this one, foliage. This one, water. And for this one, alt, what the fuck? None. And the texture container, we need to fix that one as well. Okay. Because then we can do something beautiful. Set material reference. Set material reference. Yeah, we're gonna make this one so much prettier. So set material. Set Set material properties. And we just sent down one nice material. Set material properties. Why do I need this one here? Rain data contain. Oh yeah, of course. Set material properties. Material. Compute buffer. No. We wanna do. Okay, and here we do macro type dot shader property name. Compute buffer. But we also want to set some other stuff. So the stuff we want to set here is activity, terrain activity data, HLSL. We want to set all of these. So whoa, one sec. Fuck. Compute buffer. Which one uses compute buffer? Is it water currently? Terrain data buffer container. It's water none. Okay, so it's water. It's actually terrain data water HLSL. Terrain data. Terrain water data. Yeah, it's the same either way. These four, they are the same for buffers and textures. And this one as well. So here, but I do wonder. Yeah. Material dot set. So it's always float 2. Set, is it vector? Macro type dot. First is size, shader property name. We should have this one somewhere. Do we have it? Whoa. Yeah, okay. This one is very specific. Otherwise, we could just do it here. We could probably do width, height, length, size. Yeah, we can probably do it like this. Yeah, let's. Why not? We already have one virtual, so we can do another one. Set material properties, virtual. So all we need to do here is this, and then we do base, set material properties, material. Because it's going to be a buffer here, it's going to be a texture for the other ones. but this one, this one, this one. So size, shader, property name, scale, I thought, ring data type, UV scale, shader property name, offset, and we don't have delta, that sucks. So let's add that one. To do, check if needed. I think they are. But we're gonna clean this up eventually. UV step. So we have UV scale, shader property, UV offset, shader property, and UV step. Did I call it delta here? Yeah, that's wrong. Okay. And then we want to calculate this, and we have the calculation. I think it's correct, it might be wrong, but basically this. So let's take these. Yeah, we don't want to do it like this, so we're gonna do... Okay, as for the size, we can do size vector 2 int. Size vector 2 int. Do we need it as vector 4? I think we should have a constructor for this, but I'm not sure. Like vector 4 that takes a vector 2. We'll find out. No. Okay. Then let's do... Then we have UV scale. This one is like this. Let's take this and put it here. New vector 4. 0, 0. And then we have width. Height. I'm gonna leave these nodes here because these might be wrong. Okay, so that's scale. Now I have UV offset. .5 times width. And finally step. This one uses UV scale, which sucks. So we're gonna do it like this. This time around we're gonna be a little bit cleaner. One. So here we want to take this one. Oh, 1 sec. Oh, yes, vector 2 is fine. You can handle vector 2. Okay, that's great. Here we have UV scale, so then we just do UV scale. UV scale with I. That's about it, I think. Size, UV scale, UV offset, UV step, and then in each of these we also set the base data container pretty much. So for this one, set material, so not set buffer, we do set texture, or material set texture. Okay. Because then in terrain patch, set material, set data reference in material. These are gonna be way nicer. But I want to remove I want to remove both of these. I want to replace them by one, and setting the material like this should never, like clearing and applying data at the same time. Let's just have one of these methods that does one thing and one thing only. So I'm gonna keep these two around for now. What we're gonna do: set material, material. This one we're gonna call original material, and then of course I want the dependencies. Let's keep it on 2 lines. The first thing I want to do is exactly this. We want to create a copy and bring over the but we're not going to name it material copy, but this is going to be material, and this one is going to be original material. So terrain base is going to create a ground material pretty much. Then we send it down to all the terrain patches. They are going to create their own copies of it and apply it to their mesh renderer. And then we want to do this stuff. So we're going to have for each, but we don't do this. So for each terrain data type in terrain data type dependencies. Here we do if as data, very important. If so, data type dot set material properties material, and that's about it. Yeah. Yes. So it's pretty much for this terrain patch, set this material. This material has these dependencies. So then we copy the material, we copy the properties it already has, because the terrain base is gonna set some of the properties. And then we go through all of the data dependencies for that material, and we set those references so we link the material with the correct data containers, pretty much. And that's about it. So we can do this. And then we'll probably get some errors. Let's see if we can fix them real quick. Weather effect. Yes, we're gonna rework this one eventually, so this one we can just comment out. And we don't set any materials in terrain base currently with the new system. Okay, great. At this point, I really need a break, so we're gonna continue this tomorrow. I think the last things, or the things we have left, we're gonna go through them pretty quickly. So I wouldn't be surprised if we can start with some game logic related stuff on this week even. But yeah, pretty nice 6 hours, productive I would say. Thank you so much everybody for watching, really appreciate it, and have a great rest of the day. Peace.